Hidden far below the waves rests an unknown realm we were never supposed to witness. A mysterious domain where sunlight vanishes completely and organisms develop shapes that defy all logic. As we plunge further, passing through the sunlit layer, followed by the dim layer and then the pitch-black layer, the beings we meet grow increasingly bizarre with every step downward. Humans have dispatched probes across the Martian landscape and charted faraway star systems, yet our own deep waters remain largely untouched. We have surveyed under 5% of them. In fact, our knowledge of the lunar surface surpasses what we understand about the environment 6,000 feet beneath the waves. Near the top, the sea sparkles with vibrant activity. Daylight powers massive plankton surges that sustain schools of fish, supporting complex chains of consumption from vibrant reefs all the way to massive marine mammals. But once we sink past 200 meters, the illumination starts to dim. We enter the dim layer, an immense band of water reaching roughly a kilometer down. Sunlight here lacks the strength for plant growth. The dense plankton layers disappear. No vegetation exists, no solar-powered nourishment. Instead, a gentle rain of debris descends from higher levels, microscopic bits of organic matter and deceased remains. Researchers term this phenomenon ocean snowfall. To human eyes, it appears trivial. For the residents of this depth, however, it represents the very essence of existence. And wherever sustenance appears, so does vitality, though in forms utterly alien to us. The inhabitants of the dim layer have developed some of the planet's most bizarre body plans. Numerous species are see-through, their tissues resembling clear crystal. The transparent squid glides along with internal parts faintly outlined, like a spectral presence in the azure. The transparent octopus fades almost entirely from view, its eyes standing out as the sole distinct elements. Scientists still puzzle over why transparency appears so frequently in this habitat. It could serve as concealment, allowing them to melt away in the weakest glow. Or it might help save resources in an environment where maintaining color demands more energy than it returns. Other species adopt the reverse tactic. Rather than blending into nothing, they generate illumination. In the shadows, certain animals manufacture their own radiance via a biochemical process called living light. To observers, the effect is mesmerizing. Pulsing specks, radiant designs, whole forms pulsing like floating beacons. Yet in these conditions, illumination equals existence. Some deploy it to attract meals, others to locate partners, and still others to erase their presence. One clever method involves matching the overhead faint shimmer. Predators scanning upward often notice dark shapes against the subtle background light. To counter this, creatures such as the glowing squid blanket their undersides with light-emitting tissues. They fine-tune the intensity to blend seamlessly with surface reflections, wiping out their contour and dissolving into the surroundings. This represents disguise through replication, producing brightness to merge with brightness. Different organisms employ even odder tactics. One comb jelly radiates a vivid crimson hue. At these depths, red wavelengths fail to travel, rendering the creature pitch dark. Any luminous food inside its gut stays concealed from hunters that could otherwise spot the shine. In a setting ruled by visibility or its absence, every evolutionary solution centers on controlling who detects whom. Beyond mere optical deceptions, the dim layer stages some of the sea's most impressive displays. Every evening, as surface darkness descends, countless millions of animals ascend from below. Lanternfish, cephalopods, jelly-like forms, and vast legions from the abyss swarm upward to feast on plankton beneath the cover of night. Come morning, they descend once more, fading back into obscurity.
This enormous nightly migration ranks as the planet's biggest coordinated relocation, dwarfing every land migration of mammals, birds, or insects in sheer volume. Remarkably, this phenomenon stayed undetected until naval technology during global conflict picked up an unexplained shifting layer on sonar, a thick band that ascended nightly and retreated at dawn. It was no geological feature. It was an entire living system shifting in unison. Here, the usual laws of biology start to warp. Transparency becomes protection. Glow serves concealment. Billions of organisms pulse up and down in a cycle far older than our species. This marks the gateway to greater depths, the first frontier of a universe we have yet to fully grasp.
Once sunlight ends around 1 kilometer, we arrive in the pitch-black layer, extending to about 4,000 meters. No cycles of day or night exist, only perpetual obscurity. Cold hovers near the freezing point. Crushing forces multiply hundreds of times beyond surface levels. To our perspective, such conditions appear incompatible with survival. Nevertheless, natural selection reaches peak inventiveness precisely here. Consider the dragonfish. It generates crimson living light, invisible to most deep-sea vision, turning its beam into a covert tool for spotting targets without revealing its position. Its own eyes have specialized to perceive this otherwise hidden spectrum, as if it engineered a private channel detectable solely by itself. Additional hunters excel at vanishing. Certain fish wear skin so profoundly dark it bounces back under 0.5% of incoming light. A submersible's beam aimed straight at them barely registers. Then come the anglerfish, among the ocean's most peculiar predators. The larger female suspends a shining bait before her jaws to tempt victims. Yet her most remarkable trait involves mating. Tiny, frail males exist only to locate a partner, an improbable quest in endless darkness. Upon success, he clamps on with specialized teeth, merging tissues until he shrinks into little more than a sperm reservoir, sustained entirely through her circulation. Few other examples illustrate such radical reproductive strategies in nature. Not all residents hunt actively. Many act as opportunists, lingering for whatever descends. A lone whale body plunging to these levels transforms into a temporary haven, nourishing diverse groups across many years. Still, even advanced underwater vehicles reveal only fragments of this layer. For each known organism, experts suspect many more await discovery. Every expedition surfaces specimens never catalogued before, beings with luminous eyes, razor fangs, or frames so delicate they collapse under normal pressure. This is the pitch-black layer, a place where radiance functions as a tool, absence of form grants safety, and mating defies conventional understanding. At roughly 4 kilometers, the water column yields to the seafloor, the vast muddy plains, among Earth's biggest environments, blanketing over half the globe's area yet remaining poorly mapped. No distinctive features break the monotony. No reefs, no underwater forests, no peaks. Merely endless sediment plains extending vast distances. Cold stays below 4 degrees Celsius. Nourishment arrives sporadically. Life demands unique approaches found nowhere else. One common trait is exaggerated scale. Many bottom dwellers dwarf their shallow water counterparts. Huge wood lice-like creatures the size of small dogs crawl over the ooze. Scavenger crustaceans, usually miniature, stretch beyond a palm's length. Even legendary giant squid may roam these realms. This pattern, known as deep-sea giantism, still puzzles researchers. It might aid energy efficiency or offer protection where threats are few. The exact cause stays uncertain. Occasional windfalls occur when large surface animals descend. A beached whale carcass draws crowds within hours. Sharks, slime eels, tiny scavengers. Soon, specialized worms bore into the bones, consuming trapped fats. Whole temporary communities flourish around one skeleton for decades before nothing but remnants remain. Elsewhere, creatures manage with modest fare. The so-called vampire squid, far from aggressive, sweeps up falling particles with extended adhesive threads. Even in low-oxygen waters, it prospers thanks to a blood protein unmatched in oxygen-binding efficiency among its relatives. In this silent, muddy expanse, existence proceeds at a leisurely pace. Growth is gradual, breeding infrequent, and some individuals endure for hundreds of years. Certain sharks dwelling here may exceed 4 centuries, the longest known among backboned animals. Time appears to slow dramatically, yet the plains teem with unseen activity. Every sediment particle shelters microbes that cycle essential elements, underpinning a concealed network we are only starting to understand. These flatlands underscore our planet's immensity. They span more ground than all terrestrial biomes together, yet stay mostly invisible and uncharted.
Further still lie the narrow chasms formed by shifting crustal plates, where one section slips beneath another, dragging the seabed into extreme lows. This begins the Hadal realm, drawing its name from the ancient god of the underworld. Depths range from 6,000 meters to nearly 11,000 meters at the lowest point. Dropping Mount Everest into the deepest trench would still leave its summit over a mile submerged. Conditions challenge belief. Near freezing chill, pressures 1,000-fold greater than at sea level, instantly lethal for unprotected humans. Nonetheless, organisms not only persist but flourish. Snailfish occupy the greatest depths among vertebrates, soft-bodied and delicate-looking with nearly transparent exteriors. They seem ill-suited for such hostility. Yet they endure thanks to flexible skeletons and special cellular stabilizers that preserve function under immense force. Smaller but equally remarkable residents include swarms of crustacean-like amphipods. Recent analyses have even detected synthetic fibers within them, showing that human debris reaches even these isolated spots, a stark sign that remoteness offers less protection than once assumed. Along vent sites on the walls, existence grows weirder still. Microbes here derive energy from Earth's internal chemistry. Sulfur compounds, methane, dissolved metals, and scalding fluids, rather than light or falling debris. Tube worms, bivalves, and crustaceans rely on these tiny chemists. This creates a web sustained by minerals instead of solar power, proving life can arise in environments completely foreign to surface norms. Such findings raise intriguing possibilities. If adaptation succeeds under terrestrial extremes, might similar processes occur in subsurface seas on distant icy satellites warmed by internal forces? Exploring these trenches offers a window into potential alien oceans. Despite their significance, the chasms remain scarcely known. Fewer explorers have reached the deepest trench than have walked on the moon. Each descent yields previously undocumented species, from drifting cucumber-like forms resembling parachutes to shapeless masses lacking obvious structure, or microbes with unknown energy pathways. For ages, people pictured these depths as barren abysses, empty tombs under the waves. Instead, we encounter extraordinary toughness, organisms that flex, transform, and re-engineer themselves to withstand forces beyond normal limits. After all our observations, the deep ocean continues to pose endless riddles. Over 80% of its volume stays unexamined. Every plunge or robotic mission surfaces life forms that shatter expectations. See-through swimmers, radiant segmented creatures, gelatinous beings violating biological norms. Here, new findings arrive steadily rather than rarely. Even for documented species, countless questions linger. What drives the tendency toward massive proportions in so many? Why do some vanish into near invisibility or coat themselves in darkness-absorbing layers? The most widespread enigma involves living light itself. Roughly 3/4 of deep inhabitants produce it, yet purposes differ enormously, from capture to evasion, pairing to endurance. We lack full explanations for the intricate chemistry involved or the ability of certain species to emit wavelengths imperceptible to others. Deeper enigmas persist without answers. Maybe their very unknowability gives them strength.
They serve as reminders that our home planet still conceals wonders, treasures deserving safeguarding and continued exploration.